frequency it contributes minus tan inverse of omega t. Why minus? Because the factor is in the denominator. Now suppose I tell you first order factor in numerator. Same thing, similar equations but with plus sign. Explanation is also same. Angle will be plus tan inverse of omega t, and magnitude contribution will be 20 log of omega t after omega. Okay, before that omega it doesn't contribute anything, and so that is why that frequency is known as corner frequency. Okay, so now same here, I'm scrolling it up because we have just now discussed. Magnitude will be plus 20 log omega t and phase will be plus 20 log of tan inverse of omega t. Now this is the table which you can refer for the factors just now what we have discussed about. Okay, this problem later on we will see, it doesn't matter. Now we have covered the point till which we can, up to which we can at least understand what the Bode plot is. Just a minute. Okay, so now till now what we have discussed is transfer function is collection of all the various factors. Each factor contributes to magnitude as well as phase, and addition of all contributions from all the factors makes a magnitude plot, and addition of all the factors phase contributions of all the factors makes a phase plot. So we have two different separate plots, and now we have seen how each factor contributes to the magnitude as well as to the phase. Okay, so now that's all for this particular session. Let us just decide on the group, you decide, and Shivam will convey it to me that at what time you would like to have another session. I am ready after 3 o'clock. Okay, anytime after 3 o'clock you can tell me, we can have 45-minute session, and in that session now directly we will go to a problem. By the time you can just take a look in the book if you have, or the notes which are in front of you. If you have any doubt, please convey it to me on WhatsApp. I'll explain the doubt in the next session directly. If multiple people have same doubt, then that can be clarified in the next session. I'm unmuting all. You can give your feedbacks now.
Okay, ma'am.
Yeah.
Okay, ma'am.
Yeah. Have you understood what we have discussed till now?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay. Now the theory part, what you should be clear to you is given in the Bode plot. Bode plot PPT is there. I don't think there is any need to share, but anyway, I'll share it later on. PPT has only, I have just created a PPT just to show it to you. So PPT will give you the basic idea, and the notes that are given to you has the complete description of what we have just now discussed. You might not have understood it completely, I understand, but when we solve the problem, that time you surely will understand. And as for the problem, what I'm going to do, I'm going to solve a problem with my hand. I'll take a photo of that and I'll share that screen with you, so that step by step we can understand exactly what we are doing. One more request, for the next session onwards, please keep your calculators with you. Okay, so as when I explain something to you, you can just right away calculate it on your calculators and check whatever I have written is right or wrong. You can verify that. Okay, but till now, is it clear that how factors are contributing?
Yes, ma'am. Yes, ma'am.
And only one thing, only
Yes,
one
ma'am.
thing I would like to ask, the last part, the approximation wala part, which I have explained, is that clear to you? Omega t less than 1, omega t greater than 1, it might not be clear to everyone, I understand, but while solving the problem, we will realize exactly what happens. I'll just brief you about that point. Suppose if you have a corner frequency of 5, your equation is in the standard time constant form, right? So you have time constant. If you have time constant, you can calculate frequency also. Reciprocal of that time constant is equal to frequency. What that frequency indicates, it is a frequency before which that factor is not active. That factor is inactive. It is not contributing to the magnitude as well as phase plot when before that frequency. Once that after that frequency in the frequency plot, that factor starts contributing, right? So as an example, if I tell you, just last 2 minutes now. Okay, so now suppose if you have 3 frequencies, suppose if you have 3 frequencies, 1, 3 and 5. So the factor that you have, you will forget about the factors right now. We have 3 different frequencies because time constants were 1, 1 by 3 and 1 by 5. So frequencies that we calculated is reciprocal of the time constant, that is 1, 3 and 5. Now what do I mean by factor contribution? Up to frequency 1, okay, no factor is contributing. Okay, at frequency 1, this particular factor will start contributing. These 2 factors are still inactive. At frequency 3, this one and this one both are contributing because this starts contributing at 3, right? And so
Yeah.
the magnitude plot will be addition of magnitudes of these 2 factors, contributions. Okay, same goes for phase. Till 5, this continues. At 5, this will also come into picture and all 3 factors will start contributing in the magnitude as well as in phase. Suppose if next corner frequency is say 101. So up to from 5 to 101, only these 3 factors will contribute. This factor will not contribute. This factor will contribute only when the frequency is 101. After 101, all 4 will together contribute. Is that clear now? Is that clear now?
Yes, ma'am.
Okay. So now let us stop here. Okay. You can have the session after 3. You just the next session is anyways arranged at 3 o'clock. So 3 o'clock would also be fine. We again will have a 45-minute session. I'll find out the better way to represent a particular problem or something in PPT also I can prepare. But just let me know which part you have not understood or which part you need more explanation on. Once we solve one problem, it should be easier for you. Keep your calculators with you. Keep your notes in front of you. Okay. So that's all. You can leave the meeting now. Shivam, please give me the feedback in some time on WhatsApp.
Yes, ma'am.
Okay. Thank you all.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am. You all can leave the meeting now.